compare them. So we're saying like greater than or equal to in this case. So down here, if this whole condition is true, in other words, if the results of these two comparisons end up being true, then we know that num1 is the biggest. So I can just return num1. I can say return num1. But we also want to check some other conditions. So I can say elif, and now I want to do some other comparisons. So I'm going to say else if num2 is greater than or equal to num1, and num2 is greater than or equal to num3. So I'm doing essentially what I did up here, except for num2. So again, I'm comparing these different numbers, and this is going to end up being a true or a false value depending on the result of the comparison. So down here again, we can just return num2, because if all of this is true, that means we're going to end up returning num2. And then finally we can just say else. So if num1 isn't the biggest and num2 isn't the biggest, then we can pretty much assume that num3 is the biggest. So now we have our function. So down here, I'm actually just going to call this function. So I'm just going to say, actually I'll print out the result. So I'll say max num, and we'll pass in like 3, 4, 5. So we're basically calling that new function that we just made. And I'm going to go ahead and run this program. So you can see down here in the output, we printed out 5 because that was the biggest. If I was to change this middle one to the biggest, so we make the middle one 40, now it'll be able to take on that situation. And finally, I can make this like 300, and it'll be able to handle that. So no matter which number, num1, num2, or num3 ends up being the biggest, it's able to tell us without a problem. So these comparisons are a really, really, really common way to make if statements. And a lot of times you're going to want to be comparing different values inside of Python. So over here, we're comparing numbers, but we could also compare strings. So I could easily make these both like, I could make this like dog, and I can make this dog, and I could say a different operator. So I could say like this double equal sign would mean equal. So I could basically say like, if this string is equal to that string. So you can basically like compare all different data types. I could compare numbers, strings. You could also compare Booleans. So once again, these are comparison operators, and this one is greater than or equal to, but there's a bunch of other comparison operators we can use. So the most basic is just going to be a double equal sign, and that basically checks to see if the two values are equal. So it'll say like if number 1 is equal to number 2. We can also say not equals, and this exclamation point will basically mean not equal. So it's if num1 is not equal to num2. We also have greater than, less than, greater than or equal to, less than or equal to. And those are kind of all of the operators, or all the, the basic comparison operators that you're going to be using in Python. So using comparisons is really awesome, and there's going to be tons and tons of situations inside of Python where you're going to want to compare different values. So these can be extremely useful. In this tutorial, I'm going to talk to you guys about building a calculator in Python. Now, if you've been following along with this course, you'll know that in the beginning of the course, we actually created a very basic calculator. Basically, the user could just enter in 2 numbers, and our calculator would add the numbers together and spit out the answer. In this tutorial, I want to show you guys how to build a more advanced calculator. So this calculator is going to be able to perform all of the basic arithmetic operations. So we can add, subtract, multiply, and divide. And we'll actually allow the user to specify which one of those they want to do. So the user will enter in a number. They'll enter in whatever operator they want to use, so plus, minus, divide, multiply, and then they'll enter in the second number and we'll perform the operation for them. So this is going to be pretty cool, and it's going to show you how we can use if statements in like a practical application. So let's get started. The first thing we want to do is get input from the user. So I'm going to create 3 variables, one for the first number, one for the second number, and one for the operator. And we'll basically store the values that the user inputs into those variables. So the first one will just be num1. And I'm going to set this equal to input, and we're going to give this a prompt. So I'll say enter first number. And here's actually the thing is whatever the user enters, we're going to want to convert it into a number. So generally in Python, when we get input from the user, no matter what they put in, it just gets converted into a string. But we don't want a string because we're going to have to be adding or subtracting or multiplying these numbers together. So whenever they enter in the number, I just want to immediately convert it to an actual like number data type instead of a string. So what I can do is I can actually say float, and I can surround this entire input tag with parentheses. And now what this is going to do is it's going to immediately convert whatever the user inputs into a float. Now that's going to mean that they're going to have to insert a number, otherwise we'll get an error. But for the most part, this should work out for us. So I'm actually just going to copy this guy, and we'll go ahead and paste it over here, and we'll paste it one more time. So we're basically just trying to get 3 pieces of input from the user. So the second thing we want to get is the operator. So I'm just going to say OP for operator, and I'll actually get rid of this float because we want to keep this as a string, and I'll just say enter operator. So that's going to be like plus, minus, multiplication, whatever. And then finally down here we'll get num2, and again we're going to want to convert this to a float. So I'll say enter second number. So now basically what we're doing is we're getting the first number, we're getting the operator, and we're getting the second number from the user. So what we need to do now is we need to figure out what is inside of this OP. In other words, we need to figure out what operator the user was trying to do. So are they trying to do addition? Are they trying to do subtraction? Like, we want to figure that out. So we can use an if statement in order to figure that out. So I'm going to come down here, and I'm basically just going to create an if statement. So I'm going to say if, and we want to check a condition. So I'm basically going to check to see if this operator is equal to a plus sign. So I can say if OP equals plus sign. And now if the operator is equal to plus sign, I'm just going to print out num1 plus num2. But let's say that instead of a plus sign, they entered in something else. So we can say elif OP is equal to, and now we'll check if it's a minus sign. And so here we'll just print num1 minus num2. And actually I forgot to put a colon here. So we can just do these for everything. So now we can say elif OP is equal to division, and here we'll just divide the two numbers, so I can print out num1 divided by num2. And finally we'll do the same thing for multiplication. So I'll say elif OP is equal to asterisk, and we'll just print out num1 times num2. All right, so basically over here we have every condition, but I also want to put in an else statement. So in the case that the user enters in an operation that's not like one of the 4 that we specified up here, I just want to throw an error. So I'm just going to say OP, or actually we just say else, and here we'll just print out like invalid operator. All right, so this if statement should give us everything we want. Basically, I'm just checking to see if it's equal to a plus sign, a minus sign, a division sign, or a multiplication sign. And depending on which one it's equal to, we'll do a different operation. So let's go ahead and run this and see how we do. So I'm gonna run this program, and it says enter first number, let's enter 5, enter an operator, so why don't we just do addition, and enter a second number, let's do 23. So now it prints out the answer, 28. So our calculator actually works. Let's try another operator just to make sure. So we'll do 6, and why don't we multiply it by, I don't know, 5.23. So now we go off and we do the multiplication, and looks like we got our answer. So our calculator seems to be working. And so basically all we did was we got the input from the user, and then we used if statements to figure out what they wanted to do, right? So we could check to see if they wanted addition. We could check to see if they wanted subtraction or division or multiplication. And we could also check to see if they entered in an invalid operator. So actually, why don't we try that too? So I'll enter in like 5, and now we'll just enter in like an open and closed parentheses, and a 4. So you can see here it's able to tell, like the program's smart enough to know that that's not a valid operator. So these if statements can be really powerful, and we can use them in combination with getting the user input to create a little calculator. In this tutorial, I want to talk to you guys about using dictionaries in Python. Now, a dictionary is a special structure in Python which allows us to store information in what are called key value pairs. So essentially, I can just create a bunch of these different key value pairs, and then when I want to access a specific piece of information inside of the dictionary, I can just refer to it by its key. So the word dictionary is actually pretty appropriate here. If you guys are familiar with a normal dictionary, in a normal dictionary, you'd have a word, and then you'd have a definition associated to that word. So in this situation, the word would be the key. In other words, the word is what like uniquely identifies it inside of the dictionary. And then the value would be the actual definition. So this is gonna make more sense once we start working with this, but I just wanted to give you guys a quick introduction. So in this tutorial, I want to create a little program that will allow us to convert a 3-digit month name into the full month name. So I could convert, for example, like JAN to January, or I could convert MAR into March. Like I want to be able to have a program that can do that for us. And that's actually a pretty good use case for a dictionary. So we're actually going to create a dictionary, and I'm going to show you guys how we can do that. So the first thing we need to do in creating a dictionary is just give it a name. So I want to give this a specific name. So I'm just going to call this month conversions. And now I just want to set this equal to an open and closed curly bracket. So whenever we create a dictionary in Python, we're always going to want to create it inside of these open and closed curly brackets. And so inside of the dictionary, now we can start defining what are called key value pairs. So I can define a key, and then I can give it a corresponding value. And the way that we can do that is just by typing out the key and then typing out the value. So in our case, we're converting 3-digit month names into the full month names. So I would want to type out, for example, JAN, and then I can type a colon, and I want to type out the value I want to associate with it. So we could say January. I could basically do this for every combination. So I could say like FEB, and this would be February. And actually, after each one of these, we're going to need to put a comma. So I could do the same for March. So you could say MAR. So essentially what I can do is I can specify an entry inside of this dictionary for each one of these. So this over here would be the key, and this over here would be the value. And here's one thing is all of these keys have to be unique. So if I was to come down here and change this to JAN, this is actually going to give us a little warning. So you can see down here it says dictionary contains duplicate keys. That's a no-no when we're creating dictionaries. So you always want to make sure that the keys are unique. All right, so I'm gonna go ahead and create one of these for each one of the months, and then we'll come back and we'll talk about it. All right, so I've gone ahead and created an entry for all 12 of the months. So now we have a bunch of unique keys, and each one of those keys is associated with a different value. So this is the basics of creating a dictionary. Is we have a bunch of these different key value pairs, and now what we can actually do is we can access them from inside of this dictionary. So if I wanted to access a specific key or a specific value, all I have to do is come over here, and I'm actually just going to print it out onto the screen so we can see it. All I have to do is refer to the dictionary by name, so it's just called month conversions. And there's actually a bunch of different ways that I can access these month names. So I could access different entries inside of this dictionary. The first way is just by making a open and close square bracket, and inside here I can just type in one of the keys. So for example, inside here I could type in NOV, and what this should do is it should give us back the full name for November. So when I print this out, you'll see that we get back down here November. So I could do the same thing for any of these. We could say like MAR, and now we should get March back. So I'm able to refer to the key, and it's going to go into the dictionary, and it's going to give me the value that's associated to that key. There's actually another way we could do this too. So I could say month conversions dot get, and inside of here I could also pass in the name of a key. So I could pass in like DEC, and now we'll be printing out December. And what's cool about using this get function is I can actually specify a default value that I want to use if this key is not found. So there's going to be certain cases when we're dealing with dictionaries where you're going to put in a key that might not necessarily map to a value inside of the dictionary. So you'd put in an invalid key. So let's just try to do that. So I'll just put like LUV. That's not a month abbreviation. So when I try to run this, you'll see we get this none down here. And in a lot of cases, you're going to want to create some sort of a default value. So if I'm in this situation where I have a key that's not mappable to any values inside of this dictionary, I can actually pass it a default value. So inside this .get function, I can make a comma, and now I can pass in like a default value to get printed out. So I can say like not a valid key. And now when I put in the invalid key, instead of saying none, it's going to go ahead and say not a valid key. So this is going to give us like a default value that we can fall back on. So these dictionaries are really awesome, and the keys over here don't have to be strings. So you could also use numbers. So for example, I could say like 0, 1, 10. Like I can put any numbers I want over here as keys as long as they're unique. And then I could access those keys just like I normally would down here with this get function or with those open and close square brackets. So that's sort of the basics of using dictionaries. They can be really useful to store key value pairs. And honestly, you're going to be using them a lot in Python to store different types of data. In this tutorial, I want to talk to you guys about while loops in Python. Now, a while loop is basically a structure in Python which allows us to loop through and execute a block of code multiple times. So I could specify like a few different lines of code, and then I could put that code inside of a while loop, and it would basically loop through that code, executing it repeatedly until a certain condition was false. So while loops can be awesome, and there's a lot of situations in Python where we're going to want to loop through specific lines of code. So in this tutorial, I just want to show you guys the bare basics of how while loops work. And then in future tutorials, we're going to use while loops to create little games and stuff like that. So let's talk about while loops. When I create my while loop, the first thing I want to do actually is create an integer. I'm basically creating a variable that's a number, and you don't have to do this for a while loop, but just for our demonstration, I'm going to. So I'm just going to call this I, and I'm going to set it equal to 1. And now what I want to do is I want to create a while loop. So I'm basically just going to say while, and over here I want to specify a condition. And this is what's called our loop condition, or you can also refer to it as a loop guard. And basically, we are going to keep looping through the code inside of the while loop as long as this condition is true. So whatever condition I put in here, as long as it's true, we're going to keep looping through the code inside the while loop. So I'm just going to say while I is less than or equal to 10. And now I'm going to put a colon, and I'm going to make a new line. And so anything that's below this while loop declaration and that's indented like this is going to be considered code that's inside the while loop. And so that code is going to get repeatedly executed while this condition up here is true. So I'm just going to put a very simple line of code here. We're just going to print out the value of I. And then down here, I'm going to actually increment I. So I'm going to add 1 to I. So I'm going to say I is equal to I plus 1. So basically I'm taking this I value and I'm adding 1 to it. There's actually a shorthand that we can use in Python to do something like this though. I could just say I plus equals 1, and that's automatically going to add 1 to I. So this is like a little shorthand, and you'll see people in Python using that a lot. So over here we basically have our while loop. So I have the outline for a while loop. So we're defining this variable up here, and we're gonna keep looping through the code inside the while loop as long as this condition up here is true. So if this condition is false, for example, if I is equal to 11, then we're not gonna loop through this code anymore and we're just gonna move on. So down here, I'm actually just gonna print done with loop. So this will kind of illustrate this for us. All right, so let's go ahead and run this program. I'm just gonna run it, and you'll see down here we get some output. So we're actually gonna get numbers printed out 1 all the way down through 10, and then we're printing out done with loop. So basically what's happening is we're printing out every time we go through this loop. So initially I is equal to 1, right? The first thing that Python's gonna do when it gets to this while loop is it's gonna check this condition. So before it does anything else, it's gonna check this condition and it's gonna say, okay, is 1 less than or equal to 10? And that's true. So as long as this guy is true, we're gonna go through and loop through all the code inside of here. So we're gonna print out I, which has the value of 1, and then we're gonna add 1 to I. So now I is gonna go from 1 to 2. Now what we're gonna do is we're gonna go all the way back up here to this while loop declaration, and we're gonna check the condition again. So remember, I checked the condition the first time, and then I loop through all the code. Then I go back up to the top and I check it again. So I'm gonna say, okay, is I less than or equal to 10? At this point, I is equal to 2. So I is less than or equal to 10. So now we're gonna go through and we'll execute all this code again. So I'm gonna print out I, so it's gonna be 2, and I'm gonna add 1 to I, so now we have 3. Then Python's gonna go all the way back up to the top and it's gonna check the condition again. So on every iteration through the loop, before Python does what's inside of this loop, it's gonna check that condition. And as long as the condition remains true, we're gonna keep executing the code inside the loop. Eventually though, in this program, I is gonna end up being 11, right? So on the last iteration, it's gonna end up being 11. We're gonna come back up here and we're gonna say, is 11 less than or equal to 10? Nope. And so since it's nope, we're gonna come down here and we'll print out this done with loop line. So that's the basics of how these while loops work. We're specifying a loop condition. As long as that condition's true, we'll keep executing the code inside of the loop. And after every execution of the loop, we're gonna come back up and check the condition again. So that's how we end up with this printing out down here. So that's the basics of a while loop. And we can use these while loops to do all sorts of things. Like, while loops are very, very powerful. In this tutorial, I'm gonna show you guys how to build a basic guessing game in Python. And in this guessing game, we're actually gonna be using all sorts of cool programming structures that we've learned up to this point in the course. So we're gonna be using things like if statements and while loops and variables and all these cool things in order to build this game. So the basic idea is we will specify like a secret word. So we'll have a secret word that we store inside of our program, and then the user can interact with the program and try to guess the secret word. And so what we want to be able to happen is we want the user to be able to keep guessing what the secret word is and keep typing in different responses until they get the secret word right. So that's the basics of what this game is gonna be. And now let's go ahead and create it. So the first thing we want to do is create a variable to store our secret word. So I could say secret word, and we're just going to set this equal to a secret word. So why don't we make it giraffe? That's a pretty good secret word. And now what we want to do is we want to create a variable that will store the user's response. So I want a variable that will store like all the guesses that the user makes. So I'm just going to call this guess. And I'm just gonna set it equal to an empty string right now. So now we have the secret word and we have a variable to store the user's guess. And what we need to do is we need to be able to prompt the user to input the secret word. But here's the catch. What we want to happen is we want them to enter the secret word, and if they don't guess it correctly, we want to prompt them to enter it again. And so we can't just use a single input statement. We actually have to use something called a while loop. And we can use a while loop in order to continually ask the person to guess the word until they guess it correctly. So let's go ahead and create our while loop. So I'm going to say while, and after I say while, I need to specify a looping condition or a looping guard. Basically, this is something that as long as it's true, we're going to keep looping through this loop. So basically, I want to keep looping as long as the user's guess is not equal to the secret word. So as long as they haven't guessed the secret word, I'm going to keep going through this loop. And inside of this loop, what we're going to do is we're going to ask them to input the secret word. So I can take this guess variable and I can set it equal to input, and I'm just going to say enter guess. And so over here, we're basically telling the user to enter in their guess. I'm storing whatever they enter inside of this guess variable. And then what's going to happen is we're going to come back up here. We're going to check to see if the guess is equal to the secret word. If the guess isn't equal to the secret word, then we're going to do it again. But if the guess is equal to the secret word, then we're just going to break out of this loop. And so we can come down here and we can just print out a success message. So I could say, you win, because they got the secret word. So this is a very, very simple program, but this is essentially all of the code that we need to be able to build a game like this. So let's go ahead and play our game. We can run it and see how we did. So I'm gonna click play. And down here, you can see it's prompting us to enter a guess. So I'm just gonna type in some random text. We can type in whatever we want. And as long as we're not entering that secret word, it's gonna keep prompting us to enter different information. But if I enter in the secret word, so if I enter in draft, now, all of a sudden, the program's going to terminate and it's going to say, hey, you win, because we were able to guess the secret word. So that's like a really cool way for us to be able to do this. And we actually have a fully functional guessing game. But I think this guessing game could actually be improved quite a bit. A lot of times when we're making a guessing game, we want to set a limit. So in other words, I want to set a limit for the number of times that the user can try to guess the word. So let's say that the user has 3 tries, right? They have 3 guesses in order to guess the word. And if they can't guess the word after 3 tries, then they're going to lose the game. But if they can guess the word inside of 3 tries, then they'll win the game, right? I think that would be a little bit more of a fun game. So why don't we try to program that game? Basically, we're going to set a limit on the number of guesses that the user can have. In order to do this, we're going to have to create a couple more variables down here. In other words, we're going to have to store a couple more pieces of information. The first piece of information I want to keep track of is how many times the user has guessed, right? So we can just make a variable called guess count, and we'll just set this equal to 0 because initially the user won't have guessed. Down in this while loop, every time we go through the loop, I want to increment that guess count, right? So every time we've gone through this while loop, I want to increment that count because that means the user will have guessed. So down here, I'm going to say guess count plus equals 1. And this is just going to add 1 to the guess count. Actually, whoops. All right, so after each iteration of this loop, we're going to go ahead and add 1 to the guess count. All right, so that's the first variable that we're going to need. We're also going to want to store another variable, and this is going to be called guess limit. And basically, this is going to tell us how many times the user can guess the word. So it's going to be guess limit, and we'll basically just say 3. So let's say that the user has 3 tries to guess the word, 3 strikes, and you're out. So the user, if they can't get it in 3 tries, then we're going to basically say that they lose the game. And I'm also going to need one more variable here, which we're going to call out of guesses. And I'm just going to set this equal to false initially. So this out of guesses variable is going to be a Boolean, and it's going to tell us whether or not the user is out of guesses. So if out of guesses is true, that means they have no more guesses, right? They basically lost the game. And if out of guesses is false, that means that they still have some guesses left so they can keep playing. All right, so let's use these different variables in order to make our program more functional. So the first thing I want to do is when I go through this loop, I want to check to make sure that the user has more guesses, right? In other words, before I let the user enter a guess, I want to check to see that they haven't already used up all their guesses. So down here, I can make an if statement. I can say if, and inside of the condition, I want to check to see that guess count is less than guess limit. If guess count is less than guess limit, that means that they haven't guessed the total number of guesses that they have, so they have some guesses left. And if that's the case, and if that's true, then I'm gonna go ahead and give them a guess, and then we'll increment the guess count. If this isn't true, in other words, if they have reached their guess limit, then I'm gonna wanna set out of guesses equal to true. Because they're out of guesses, right? They have no more guesses because the guess count wasn't less than the guess limit. And so that means that they're out of guesses, so they have no more guesses. So there's actually one more thing we need to do inside of this while loop. We need to add another condition onto this loop guard. So right now, we're gonna keep looping as long as the guess is not equal to the secret word. But remember, if the user's out of guesses, in other words, if they've reached their guess limit, we don't want them to guess anymore, right? So if they ran out of guesses, then we want to basically break out of this loop and not give them any more guesses. So I'm gonna go ahead and add another condition onto here. And I'm gonna say, while they haven't guessed the secret word and they're not out of guesses, so it's gonna be not out of guesses, then we're gonna keep looping. So as long as they haven't guessed the word and as long as they still have some guesses left, we're gonna keep looping. But otherwise, we're gonna break out of the loop. And so down here, we're printing out you win. But actually, when we break out of this loop, there's gonna be two possible scenarios. So again, there's two possible ways that this loop could end, right? Either the guess is equal to the secret word, so either the user guessed the word correctly, or the user ran out of guesses. And so there's two situations down here that we need to account for. And so I'm gonna use an if statement to figure out which is which. So I'm gonna say if, and we're just gonna type out of guesses. And if the user is out of guesses, then I wanna print out of you lose. So we're basically gonna be like, you lost the game. Otherwise though, if they're not out of guesses, that means that they guessed the word correctly. So we're just gonna print out you win. All right, so now we have all of the logic for this little guessing game set up, and let's see if we can run it and play through it. So I'm just gonna run this program, and now it's gonna tell us to enter a guess. So why don't we enter more guesses than we have? So we're gonna try to lose the game. So I'm just gonna enter one guess, two guesses, and now I'm on my final guess. So if I don't get it here, we should actually lose the game. And you can see it says, out of guesses, you lose. So we weren't able to guess it in the number of tries that we had. Let's run the program again and we'll try to win the game. So we'll get a couple wrong. Let's say we're on our last guess and I'm like, okay, I can do this. So I type in the word and bam, we won the game. So that's how we can basically create a game where we have a guess limit. So this is a lot of code. Let me walk you guys through this one more time so you can just get a full understanding of what we're doing. Up here, I created a few different variables. We created this secret word variable, and we created this guess variable. Then, we also created some more variables. So we created this guess count variable. And this just keeps track of how many times the user has guessed the word. And you can see down here, every time we give them a guess, we're incrementing the guess count. We also have guess limit. And guess limit is telling the program how many times the user can guess. So before I go through this while loop, the first thing I'm doing is I'm checking to see that the guess count is less than the guess limit. In other words, do they still have some guesses left? If they do, then we're going to get the input from the user. Otherwise, we have this other variable up here called out of guesses. And out of guesses is going to tell us whether or not they have some guesses left. So if this is equal to false, that means they have some guesses. If it's equal to true, however, it means no more dice, no more guesses, they are done. So they lost the game. The last thing we needed to do was specify an additional condition up here. So we are going to keep looping through the code inside of this loop as long as the conditions up here are true. So as long as they haven't guessed the word, and as long as they're not out of guesses, we are going to keep looping through. And so when eventually the user does break out of this loop, there's going to be two possible situations. The first situation is that they ran out of guesses. And so we want to check to see if that's the situation. I want to check to see if they're out of guesses. If they are, we'll print out a lose message. If they're not, then they must have guessed it correctly, so they win. And so that is how we can use while loops and if statements and also variables in combination with each other to build a pretty awesome guessing game. In this tutorial, I want to talk to you guys about using for loops in Python. Now, a for loop is a special type of loop in Python which allows us to loop over different collections of items. So a lot of times we'll use for loops in Python to like loop through different arrays, or we could loop over like the letters inside of a string, or we could just loop through like a series of numbers. So for loops provide a very specific purpose. And the easiest way to kind of wrap your head around why for loops are useful is just for me to show you guys a bunch of different examples. So that's exactly what I'm going to do. We're going to look at why for loops are awesome. So down here in my text file and my Python file, I'm going to write out a couple different for loops. So the way that we create a for loop is just by saying for. And now what I want to do is specify a variable. And this variable is going to essentially represent a different value every time we go through this for loop. And you guys will see how that works in a second. But just know that this variable is going to be used on every iteration of our for loop. And each time it will most likely have a different value. So in our case, I'm just going to call this letter. And I'm going to say for letter in. And now what I want to do is I want to specify a collection that I want to loop over. One example of this would be like a string. So I could put a string in here. I could just put like Draft Academy. And now I can just put a colon. And so basically what this is going to say is it's going to say for every letter inside of Draft Academy, I want to do something. And so down here inside of this for loop, and again, we need to indent this, we can put what we want to do with each letter. So let me just show you guys like basically what this is going to do. So I can print out letter. So I can print out this letter variable, and it's actually going to print out a different letter inside of this Draft Academy string on every single iteration of this loop. So I'm going to run this program, and down here inside of my console, you'll see that I'm basically printing out Draft Academy. So on the first iteration of the loop, I printed out the first letter in Draft Academy, which was G. On the second iteration of the loop, I printed out I, third was R, fourth was A. So I'm essentially just looping through all of the letters inside of Draft Academy. So I'm saying for each letter in Draft Academy, I want to print out that letter. And so this is kind of like how for loops can be used. We can define a variable, and that variable will change on each iteration of the loop, right? So on the first iteration of the loop, this letter variable represented a G. On the second iteration of the loop, the letter variable stored the value I, etc., right? So we went through this entire string and we were able to print out each letter. So in addition to using this with strings, we can also use this with other collections, for example, like an array. So if I created an array up here, let's just call it friends, I'm going to set this equal to a bunch of different values. So we can put like a list of our friends in here. We can say like Jim, Karen, and Kevin. Instead of saying letter, why don't we call this friend? And I could say for friend in friends. And now we'll print out the friend. So over here, I'm saying for each friend inside of this friends array, I want to print out the friend. So now we'll actually be able to print out each element inside of that array. So down here, you'll see we're printing out Jim, and then on the second iteration, we're printing out Karen, and on the third, we're printing out Kevin. So I'm able to loop through all of the values inside of the array. And just so you guys know, like, you can name this variable whatever you want. So I could give this like any random name. And if I want to access it though, I have to access it using that same name. So we can loop through something like an array. We could also just loop through a series of numbers. So I could say index over here. And again, this can be anything. I'm just going to call it index. So we could say for index in range, and then in here I can pass in a number. So I could pass in like 10, for example. And down here, I'm just going to print out the index. When I run this program, you guys will see that it's basically going to print out every number in the range from 0 to 10, not including 10. So starting with 0, it's going to print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But notice that it didn't print out 10. So it's essentially just printing out all the numbers between 0 and 10, not including 10. You can also specify a range of numbers. So I could say, for example, like 3 and 10. And now this will print out all the numbers between 3 and 10, not including 10. So we'll run this program. And you can see we print out 3, 4, 5, 6, 7, 8, 9, and not 10. So whatever value that you put here in this second position is not going to get included in the range. And ranges can be really useful. So for example, I could use a range to loop through an array just like we did before. So if I wanted, I could say something like for index in range, and now inside of this range, I can pass in the length of the array. So just so you guys know, if I wanted to get the length of this array, in other words, if I wanted to figure out how many elements were inside of it, I could just type out len and then inside parentheses, the name of the array. And so this is gonna spit out 3 because there's 3 elements inside of here, right? Kind of makes sense. So what I can do is I can say down here inside of this range function, I can just type in len and then friends. And so what this is gonna do is it's gonna essentially give me a range between 0 and the number of friends inside of this list. So down here, I could actually type out friends index, and this will allow me to access each individual friend inside of this list, just like we did before, but now I'm doing it with a range. So you can see I'm typing out Jim, Karen, and Kevin. So actually, for each iteration through this loop, it's basically gonna be printing out friends 0, friends 1, and then friends 2, because in here we're passing in a 3. And remember, whatever I pass in there, it's gonna range from 0 all the way up to that number, but not including that number. So that's another way that we could print out all the elements in the array. And looping through something like an array is actually a very, very common use case for loops. But like I said, we can use for loops to loop through essentially any collection that we have. So we could loop through like a string. We could also loop through, something like an array. So this can be really useful, and that's sort of the basics of for loops in Python. And I also want to show you guys one more example just while we're here. So why don't we go ahead and print out a range up to 5, right? So this will just be a simple program. You can use all sorts of logic inside of these for loops. So let's say that I wanted to do something special on the first iteration of the loop. So I could say if index is equal to 0, and if the index is 0, then we know it's the first iteration of the loop. So I could do something special. I could like print out first iteration, and then otherwise we could just print like not first. So this would be an example of like, maybe you want to do something on the first iteration of the loop and do something else on subsequent iterations. So if I play this, you'll see only on the first iteration is it printing this out, and otherwise it's printing out other stuff. So, don't be afraid to put some complex logic inside of these for loops, because it can really make your programs more powerful. In this tutorial, I'm going to show you guys how to build an exponent function. Now, an exponent function is basically going to allow us to take a certain number and raise it to a specific power. So in Python, there's actually a really easy way to do this. I could come down here and I could print, we could say like 2 and we can just do 2 multiplication signs, and I could say 3. And this is basically just going to be 2 raised to the 3rd power. So you can see here, I can just print this out and we get 8 because that's 2 cubed. So it's really easy to do exponents in Python, but I want to show you guys how we can use something like a for loop in order to create a function like this of our own. So we'll actually create an exponent function that will basically do this, and we'll use for loops to do it. So let's create a function. So I'm just going to say def, and now we need to give this function a name. So why don't we call it raise to power? And inside of here, I'm going to accept 2 parameters. The first parameter is going to be the base number, and then the second parameter is going to be the power number. So we're going to take the base number and raise it to the power number. So over here, we can just make a colon. Now, inside of this function, we need to start writing some code. Here's the thing. Inside the function, we don't necessarily know the value of this pownum, right? For example, if we knew that we were just trying to like square this number or cube this number, I could just return like base num times base num, right? That would square the number, or I could cube the number base num. So this would be like the number cubed. The problem is though, we don't know like right off the bat what this value is going to be, right? This could change, like the user can decide that. So in order to write this function, we're actually going to need to use a for loop. And I'm going to show you guys how we can use a for loop to basically figure this out. So the first thing I want to do is create a variable, and I'm just going to call it result. And we're just going to set result equal to 1. So we're going to start this off at 1. Now I want to create a for loop. So I'm basically just going to say for, and over here, I basically want to specify like a index. So I'm going to say index in, and now I want to specify a range. And a range will basically range us through a collection of numbers. So basically I want to multiply the base num by itself as many times as the pownum specifies, right? So over here, I can just make this a range of pownum, right? And so we'll basically loop through this for loop as many times as pownum. So if pownum is 2, we'll loop through it twice. If pownum is 4, we'll loop through it 4 times. And every time through the loop, we'll multiply base num by itself. Or actually, you'll see we're going to multiply it by this result. And so down here inside of this for loop, I can basically say result is equal to result times base num. This should actually give us everything we need to take this number to the specific power. So the actual like result, of doing the math is going to get stored inside of this result variable. So the first time through the loop, we're just multiplying base num by 1, right? And so now result is going to become the same value as base num. The second time through the loop, so this would be if we were squaring the number, we're basically multiplying result by base num again. So it's essentially just base num times base num. The third time through the loop, we're multiplying result times base num. So we're essentially just like cubing the number. So that's essentially what this for loop is doing for us. So the last thing I want to do is right here below this for loop, I'm just going to return the result. So we'll be able to return whatever the result of raising the number to the power was. All right, so let's come down after this function and we're just going to call it. So I'm just going to say, actually we'll print out the answer. So I'm going to say raise to power. And inside of these parentheses, remember we can pass 2 numbers. So let's raise 3 to the second power. So we're just going to square 3 and we'll see how this works. So let's run the program. And you can see down here in the console, we're getting 9. Let's try something a little bit crazier. Let's try 3 to the 4th power. And we'll run this and we get 81. So that's 3 to the 4th power. Let's try 2 to the 3rd power. And we're getting 8. Yeah, so that makes sense. So our raise the power function is working just as expected. And I'll just walk you guys through it one more time. So inside of this function, we're taking in 2 pieces of input. We're taking in a base number and we're taking in a pow number. So that's like the base number is going to be taken to the power number. I'm defining a variable here called result. And result is where we're going to store the actual result of doing the math. Now we specify this for loop, and I'm basically saying that I want to loop through this range of numbers. When I put pownum here, it's basically going to range from 0 all the way up to, but not including the power number. So we'll basically loop through power number of times, if that makes sense. And then every time through the loop, we're just multiplying result by base num, and then we're just returning result. So that's the basics of building a power function. And obviously, like, if you're just trying to take a number to a power in Python, it's really easy, but this kind of shows you like the internal workings, right? For a function like that to work, we would have to actually type something out just like this. In this tutorial, I want to talk to you guys about two different concepts in Python. It's going to be a pretty cool lesson. First thing I want to show you guys, though, are two-dimensional lists. So down here in our Python file, I just want to create a basic list. So I'm just going to call this number grid. And I'm just going to set this equal to a normal list, right? Just like this. Now, normally, if we were creating a list, I could just put in a bunch of attributes and a bunch of elements, right? And now all of these elements are inside of this number grid list. Everybody's happy. But another thing I can do is I can make all of the elements inside of this number grid list lists. So the first item in the number grid list is going to be a list. The second item in the number grid list is going to be a list, etc. So I'm going to show you guys how to do that. I can basically just come down here, and where I would normally put the first element in the list, I can just create another array. So I'm just going to make an open and closed square bracket. And now I'm just going to say 1, 2, 3. And I can create the next item in my list. I can say 4, 5, 6. And let's make another item in this list. I can say 7, 8, 9. And finally, we're going to put one more list inside of the number grid list, and it's just going to have 0 in it. So inside of this number grid list, right, this high-level overall list, we have 4 elements. And all of those elements are themselves lists. So essentially what we're doing is we're creating a grid, right? This grid has 1, 2, 3, 4 rows and 1, 2, 3 columns. Right? 4 rows, 3 columns. And that's kind of like why these can be useful, is we can create a grid-like structure inside of Python using two-dimensional lists. So this is a pretty cool list structure, and I want to show you guys how I can access individual elements inside of this list structure. So for example, let's say I wanted to print out one of these values. Let's say I wanted to print out this 1 right here. The way I can access it is by saying number grid, and the first thing I want to do is make an open and closed square brackets, and in here I want to put the index of the row that I want to access. So this would be like row 0 because that's the 0th element in the array. This would be row 1, it's at index position 1. This would be row 2, row 3, etc. So I could put row 0, and now right next to this I'm going to make another square bracket, and I want to put the index of the column. So this would be like column 1, column 2, column 3. So I'm going to put another 0 because this is at the 0th index of this first array. So I just put 0, 0 here. Now we can print this guy out to the screen, and you'll see down here that we get that 1. So I could also do this for this 8, for example. So this is going to be 0, 1, 2. It's going to be row 2 and column 1. And now we should be able to print out that 8. So that's basically how we can access elements inside of this 2D list. The next thing I want to show you guys is a nested for loop. A nested for loop is a situation, like I said, where we have a for loop inside of a for loop. And I'll show you how we can use this nested for loop in order to print out all the elements inside of this array. So I'll basically show you guys how to parse through a two-dimensional list or a two-dimensional array. All right, so basically we're just going to create a normal for loop. So I'm going to say for, and I'm just going to say row in number grid. And I'm using the word row here because I'm kind of seeing these guys as rows, right? These are sort of horizontal rows in our little grid. So for each of those rows, for each of the elements inside of number grid, I want to loop through. So I could actually just print out each row right now, and it's just going to print out all the rows inside of this list. So you can see down here we basically just get exactly what we have up there. But I want to be able to access each of these individual attributes inside of each of these array elements. So we can actually create another for loop, and I'm going to put that for loop inside of here. So now I'm going to say for column in row. And basically what this is going to give us is each individual column or each individual element inside of these arrays. So for example, inside of the arrays that are the elements of the number grid. Hopefully that makes sense. So down here, now I can just print out column, and this should actually print out every single value inside of this two-dimensional array. So let's go ahead and run this program. And down here, you'll see that we're basically printing out 1 all the way down to 0. So we're printing out all of the elements inside of all of the arrays inside of the number grid. So that's how we can use two-dimensional lists and nested for loops together. And both of those things are actually pretty handy in Python. In this tutorial, I'm going to show you how to build a basic translator in Python. So essentially we can take in a string, so we can take in like a phrase or a word, and we'll be able to translate it into a different language. So over here I have this little file, and it basically specifies this language that I made up. So I'm calling it the draft language. And in the draft language, all vowels become G. So if I was going to translate an English word into a draft word, for example, the word dog, I would look through the word dog in any instances where there was a vowel. So in our case, let's just say A, E, I, O, or U. I would convert that vowel into a G. So dog would map to DGG, cat would get mapped into CGT. So those are the basic translation rules. Obviously, this is a pretty simple language, but you get the point. Any vowel is going to become a G, and then we'll get the draft language. So we're going to build a draft translator. Over here in our Python file, let's start making this translator. The first thing I'm going to do is just define a translate function. So I'm going to make a function here, and I'm just going to call it translate. And inside of these parentheses, we want this to take one piece of information, which is going to be the phrase that we want to translate. So I'm just going to say phrase. And now inside of this function, we need to figure out like, okay, how can we translate English into our draft language? Well, remember, the rules is basically just any vowels become G's. So the first thing I want to do is create a variable. And this variable is going to be the translation. So this will be like the final result that we're going to return to the user. So I can say translation. For now, I'm just going to set it equal to the empty string. So this is just going to be like a completely empty string. It's not going to be doing anything. And now what we want to do is we basically want to loop through every letter inside of this phrase. And if it's a vowel, we want to change it to G. And if it's not a vowel, we want to leave it alone. And we're essentially going to be looping through phrase, and we're going to be adding the letters onto this translation one by one. So let me show you guys how we can do this. I'm going to make a for loop. So I'm going to say for, and I'm just going to say letter in phrase. And so now when I loop through here, I can access each individual letter inside of the phrase that they passed in. So what I want to do is I want to check to see if the letter is a vowel or not, right? If it's a vowel, then we can add a G onto translation. If it's not a vowel, then we can just add on whatever letter it was onto translation anyway. So I'm going to use this if statement. I'm going to say if, and there's actually this special thing we can do in Python. We can check to see if something is in something else. So I can say if letter in, and over here I'm just going to type out all the vowels. So we'll say A, E, I, O, U, and A, E, I, O, U. So I'm basically checking to see if the letter is inside of this string. And if the letter is inside of here, then we know that it's a vowel. So down here we can handle that case. So I can say translation is equal to translation plus G. Because if this letter is a vowel, we just want to convert it into a G. Otherwise, though, I can basically just say translation is equal to translation plus letter. So in the case where we have a vowel, I'm adding a G onto translation. In the case where we don't have a vowel, I'm just adding on whatever letter it was onto translation. So finally, down below this for loop, we just want to return the translation. So I'm just gonna say return translation. And now we have a awesome translate function, and it should probably work. So let's come down here and we'll test it out. So why don't we allow a user to input some information? So I'm basically gonna call this function. Actually, we're gonna print it out. So we'll print this out, and I'm gonna call this function translate. And inside of here, I'm actually just gonna pass whatever the user inputs. So I can just say input, and inside of these parentheses, I can say the prompt. So enter a phrase. And so now I'm basically combining all of these statements together. I'm saying I want to print out the translation of whatever the user enters in. So let's go ahead and run this program, and we'll see how we do. So I'm gonna run the program. It says enter a phrase. Actually, let me format this a little bit better. Okay. All right, so it says enter a phrase. So let's go ahead and do that. So let's just type in the example we used before. I'm gonna say dog. And so now out pops the answer, which is DGG. So that's kind of cool. And we can just keep running this as many times as we want. So I could type in like to be or not to be. So this is like a little bit longer of a string. And you can see it translates it into our draft language. So that's basically how we can create our little translator app. And that's pretty cool. And so you can see we're using a for loop in combination with an if loop, and that's a really powerful structure. And actually there's one place over here where we can make this a little bit more efficient. So instead of saying if letter in this string, you'll notice here I'm checking to see if it's in all the lowercase and the uppercase. I could actually just say if letter dot lower in, and now I only have to type out the lowercase letters, and it's still gonna do the same exact thing. So that's a little like hack or whatever that we could use. And there's also one more problem with this program. So you'll notice down here, we're setting the translation equal to the translation plus G. But the problem is if I was to start my word inside of the phrase with a capital vowel, so in other words, if I said like on, you'll notice that when this gets printed out, it gets printed out as lowercase gn. So it's not keeping our uppercase syntax. And that's kind of a problem. So we could actually use another if statement in here, and we could check to see if letter dot is upper. And if the letter is uppercase, then we can just set the translation equal to the translation plus a capital G. Otherwise, we can just set it equal to the lowercase g. And so now we're able to control both of those situations. So let's just test this and see if it works. Enter a phrase, say on, and now we're keeping that capital letter. So those are just a couple different ways that we could make this program a little bit better. But the basic concept is we have a for loop, and then we have some if loops inside of it, and we're calling this awesome function that can translate a word for us. In this tutorial, I want to talk to you guys about comments in Python. This is going to be a pretty short tutorial. I just want to give you guys an overview of what comments are and how we can use them in our Python programs. So over here in my Python program, I just have this line here. It says print comments are fun. So if I run my program down here inside of the console, it's going to print out comments are fun, right? So any code that I put over here is going to get executed by Python. But there's actually a special line of code that we can write, and it's called a comment. And a comment is basically a line inside of our Python file that's just not going to get rendered by Python. So when Python sees it, it's just going to ignore it. It's not going to execute it. It's not going to print anything out. It's just going to kind of ignore it. And comments are basically just used for us humans. So a comment is used for like me or another developer to write a little comment, a little like plain text, comment inside of a file. So in order to create a comment, I could use this hashtag symbol. So I can click hashtag, and now I am writing a comment. So I can write whatever I wanted in here. I could say like, this program is cool. And you'll notice when I run the program, that doesn't show up anywhere, right? It doesn't matter what I put after this hashtag. This is just like ignored by Python. It's just for me or another developer to come in here and use. So a lot of times if you want to write like a little note inside of your Python files, or maybe you can write yourself a little reminder, or if you want to write a line to like explain a line of code. So for example, I could write a comment that would explain this print statement. So I could say like, this prints out a string, right? Now anybody looking at my file would be able to read this and they'd be like, oh, that's what this does. Okay, cool. So comments are useful for leaving little comments in a Python file. If you want to make comments on multiple lines, you can just create a new line and use another hashtag. And so then I could type out whatever my next comment was. And generally, if you're going to put comments on multiple lines, you want to just use multiple hashtags. But there's actually another way that you can write out comments. So you can use a triple quotation mark. So I'm typing out the single quote and I'm typing it out 3 times. So you can see here, up here we have this 3 times, we have this 3 times. So in here I can, write any comment that I wanted. So I could put, as much text up here as I would want. And same thing, when I run this program, it's just not going to get rendered. So this is another way to make multiple line comments. But the official Python style guides or whatever just recommends that if you're going to put comments on multiple lines, you use these hashtags. So you can really do whatever you want, but if you want to be super Python official, then use these hashtags. Comments can also be useful for doing something called commenting out a line of code. A lot of times when you're writing a program, you might have a line of code in there that is maybe potentially messing stuff up. And so what you can do is you can actually comment out that line of code. So I could put a comment in front of this line of code, and now when I run my program, the program's gonna run, but it's not gonna use this line. So sometimes if you're trying to see if a line of code is causing you trouble, or if you wanna see what your program would be like without a line of code, or even a block of code, you can just comment it out. And that way you're not actually deleting the code from your file, you're just commenting it out, so Python's gonna ignore it. And those are really the 2 uses for comments. It's to write little notes, write little comments about different things, or to comment out code. And as you go forward in Python, I'm sure you'll find uses for comments. In this tutorial, I want to talk to you guys about catching errors in Python. Now, a lot of times when we're writing Python programs, you'll encounter different errors. So different situations could come up and your program might throw an error or it might throw an exception. And a lot of times when these situations happen, they'll completely stop your program from running. And what we can actually do is we can watch out for certain specific errors that are going to pop up in our program, and we can actually handle them. So instead of our program just breaking and stop executing, we can actually handle those errors and do things when they occur. So I want to show you guys an example of using this. Down here I'm saying number is equal to int input enter a number. Basically what's happening is I'm prompting the user to enter in a number using this input command, and then I'm converting whatever they entered into an integer. So as long as they enter in a valid integer, I can convert it into an integer. So I can convert it into a whole number, and I can store it inside of this number variable. Then I'm just printing it out. So let's try to execute this program. I'm gonna run the program, and you'll see down here it says enter a number. So we can enter in 4, for example. And when I enter in 4, everything's gonna work, and it's just gonna print out 4, and everything is right in the world. And actually I'm gonna modify this up here so it's a little easier to see. But let's say we run the program again. So it says, okay, enter your number. Let's say that I break the rules and I don't enter a number. So I just ignore what the prompt says and I put, some random text in here. Now when I enter this, the program's gonna throw an error. You can see down here it says value error, invalid literal for int base with base 10. Basically, hey, you didn't enter in an integer like you said you would, right? We told them to enter in a number, they entered in text, so it broke the program. And this is a situation that happens a lot. So there's a lot of different situations where something can just go wrong in our program. And up until now, we've just kind of accepted it as a reality. But If you're writing a real live Python program, you don't want something like this to trip up your program. You don't want the entire program to break when somebody just forgets to enter in a number, right? You want to be able to handle all these different situations. And in order to handle them, we can use something called a try except block. And a try except block will basically allow your program to try out a piece of code, and if everything goes well, then we're great. Like, we could try out entering in the number, and if the user enters in the correct number, great. But if they don't enter in the correct number, then we can basically like account for that. So if they entered in something like a string when they're supposed to enter in a number, we could tell them like, hey, you entered in the wrong thing. So I'm going to show you guys how we can use these try except blocks. I'm going to come up here and I'm just going to say try. I'm going to make a colon, and now I want to indent both of these things. So both of these things are going to be inside of this try block. Now I'm going to make a new line. I'm going to come down here and I'm just going to type out except. And I'm also going to put a colon here. And down here I'm just going to print something out. So I'll just say like invalid input. So now, since I put this code inside of this try block, if the user enters in something wrong, it's going to be able to catch it. So it'll be able to catch what the user does wrong and print out invalid input onto the screen. So let's go ahead and run our program, and it's just going to say enter a number. So we're going to ignore that. We'll enter this in. And now instead of yelling at us and breaking the program, it just says, hey, invalid input. So it was able to handle the error that got called. It was able to handle the invalid input error. Basically just told us, hey, no more input. So this is a really powerful thing that we can do in our Python programs, basically just to protect our programs, right? If I want to have my program running for long periods of time, I can't have something as simple as an invalid input trip it up. So I can catch that invalid input using these try except blocks. But here's the thing, you'll notice that this little guy down here is getting highlighted. And let's just see what it has to say. So it's basically saying too broad exception clause. And this is a message that we're getting because when I just say except, this will catch any error under the sun. So anything that can go wrong in my program, for the most part, this is going to accept it. So let me give you guys an example. Let's say I had in my program, I was creating a variable, right? So I wanted to create a variable called value, and I set it equal to 10 divided by 0. Now, if you know anything about math, you'll know that you can't divide a number by 0. It's not possible. So the program isn't going to be able to handle this, and you'll see that this is going to throw an error for us. So when I run the program, it basically says 0 division error, division by 0. We're not allowed to do that, right? If I took this and I put this down inside of this try block, and I just pasted it in here, it's going to get caught by this exception that we wrote down here. So it's going to get caught by that except. So when I run the program, you'll see it says invalid input. But the problem is that we didn't input something that was invalid, right? We just divided by 0, but it wasn't able to handle that, right? So it could not divide by 0, it threw an error. So even though we didn't get an invalid input, even though it was because we divided by 0, it still printed this out. And this brings me up to another point, is we can actually catch, or we can accept specific types of errors. So for example, in this case, we got a division by 0 error. In this case, we got an invalid input error, right? We put something in that was wrong. It couldn't convert the value. So I can create 2 different except blocks to catch 2 different types of errors. So down here, I can just make a space and I can specify the type of error that I want to catch. So when we divided by 0, it was 0 division error. So if I just put 0 division error in here, now it's going to catch that 0 division error. So I can say divided by 0. I could also make another except, so I could say except, and we can catch the other exception that we got. So I think it was a value error, right? It was, we put in the wrong type of value inside of that input. So now we can print out invalid input. So with these 2 except blocks, we're basically able to handle both of these situations. So for example, if this ends up breaking the program, this division by 0, then it'll be able to catch that. So down here, it'll tell us, hey, you divided by 0. But if I was to get rid of this line of code and I just entered in the number wrong, so I came down here and I entered in a string instead of a number, now it's gonna tell us invalid input. So we're gonna be able to specify what happens when certain things break. So when we get a value error, we can say invalid input. When we get a 0 division error, we can say divided by 0. So depending on what breaks, depending on what happens, we can actually do different things. And I want to show you guys one more thing we can do, which is we can actually store this error as a variable. So I can say except, and I can say as, and I can type in a name here. So a lot of times people will just say like ERR. And down here, I can print out the actual error. So I could just print ERR. And so if we end up dividing by 0, so if I say answer is equal to 10 divided by 0, we're gonna throw this error and it's gonna print out what went wrong. So now I can run this program and it just says division by 0. So it just printed out the error that we got. So that's another useful thing you can do, is you can actually like print out the specific error that got thrown. Now, a best practice in Python is to use these specific errors. So you always want to accept for a specific error. What you don't want to do is just say accept and then just accept anything under the sun. It's just too broad and it's not a good practice in Python. So you always want to be catching specific errors like this. In this tutorial, I want to talk to you guys about reading from external files in Python. Now, a lot of times in Python, you're going to want to read from files that are outside of your Python file. So you might want to read information from like a text file or a CSV file or like an HTML file. And you can actually use something called the Python read command, and it will allow you to read a file that is stored outside of your Python file. So you can use these files to get information, or you can parse through different files and do different things. So I'm going to show you guys the basics of reading files, opening files, closing files, doing all of that stuff. Over here, I have this file called employees.txt. And it basically just lists out a bunch of different employees. Like these could be employees in an office or whatever. So it's just listing out all of this information. So let's say that inside of my app.python file, I wanted to read the employees inside of that file. The first thing I have to do is actually open that file from inside of Python. So I can use a special command called open. So I can say open, and then in here, I can type in the name of the file that I want to open. So this is either going to be a relative path to the file, an absolute path to the file, or just the file's name if both files are in the same directory. So in my case, app.python and employees.txt are in the same folder, like they're in the same directory. So I can just type out the name of the file. I can just say employees.txt. And now I want to put one more thing inside of this open function, and it's going to be the mode that I want to open the file in. So you can actually open files in a couple different modes, and the first mode is called read. So I can just put an R here, and that's going to stand for read. And this basically means that I only want to read the information inside the file. I don't want to modify it, I don't want to change it, I just want to read it. I just want to see what's in the file and do some stuff with that information. Another mode is called write, so I can type in this W. And writing basically means that you can change the file, right? You can write new information, you can change existing information. There's another one called A, and A stands for append. And this basically means that you can append information onto the end of the file. So you can't modify any of the information in the file, you can't change any of the information, but you can add new information. And there's one more, which is R+. And this basically means read and write. So this will give you all the power of reading and writing. So in our case, we're just going to be working with regular R. So we're going to be reading from the file. Now this open function will essentially just open the file. So it's going to like go over to that file inside of our file system, open it up, and it'll allow us to read through it. But generally, we're going to want to store this opened file inside of a variable. So I can create a variable and we can just call it employee file. And I'm just going to set it equal to this open function. So now the open employees.txt file and all the content inside of it is stored inside of this employee file variable. Now, whenever you open a file, you always want to make sure that you close the file as well. So just like we have this open command, we also have an close function. So I can come down here and say employee file dot close. And this is essentially just going to close the file, so we're no longer going to be able to access it. And generally, it's a good idea whenever you're opening up a file, you want to also make sure that you're closing the file at some point. So generally, once you're done reading it, you can just close it. So that's kind of like how we can open and close a file. Now, let's talk about how we can get information from the file, right? There's no point in having the file there if we can't figure out what's in it. So there's actually a few different functions that we can use on this employee file to figure out what's inside of it. And I'm going to show you guys some of those. So I'm just going to make a print statement, and inside this print statement, we'll basically just print out some information about the employee file. So the most basic thing we can print out is just the entire contents of the file. But before I do that, I want to show you guys how you can check to make sure that a file is readable. So before we do anything else, generally it's a good idea to make sure that it's possible to read this file. And there's a function inside of Python we can use called readable. So I'm just going to type out employee file dot readable. And this is going to return a Boolean value, and it's going to tell us whether or not we can read from this file. So I'm going to run my program, and you'll see down here we get a value of true. And that's because we set the file with a read mode. So it's in read mode, we can read from it. If I was to put a W here, so if I put like write, now readable is going to be false because we can no longer read the file, we can only write to the file. So I'm going to change this back to R so we can just read it. So once you figure out whether or not the file can be read from, let's actually read it. So there's another function called employee file.read, and this is basically just going to spit out all the information in the file. So when I run the program, it's just going to spit out all of this information, right? All the information that was in that file. I can also come down here and we could read an individual line inside this file. So I can say employee file.read line. And what this is going to do is it's going to read an individual line inside of this file. So now when I run this program, you'll see it's just reading that first line in the file. And this read line function is actually just reading the first line, and then it's basically like moving a little cursor onto the next line. So if I was to copy this line of code and then print it again down here, I'm saying employee file.read line, so it's going to read the first line, and then when I say it again, it's going to read the line after that. So this is actually going to end up printing out the first two lines in the file. So when I run this program, you'll see we print out Jim salesman and Dwight salesman. So if I was to do this multiple times, like I could technically print out every line inside of this file. And you can see we can do that. And so that can be pretty useful for reading multiple lines in a file, but there's actually another function that is better at doing that. And we can say, instead of employee file.read line, we can say .read lines. And what this is going to do is it's going to take all of the lines inside of our file and put them inside of an array. And so now when I print this out, you'll see we have this array down here. It says Jim salesman, that's the first item in the array. Dwight salesman, the second item in the array. It's basically taking each line and putting it inside of an array. So if I wanted to access a specific line, I can just refer to it by its index in the array. So if I said 1, now this is going to give us that Dwight salesman line, because that is at index position 1 inside of the array. You can also use this read lines function with a for loop. So I could come up here and create a for loop. I'm just going to say for, and we'll say employee in employee file. And then for each employee, we just want to print them out. So, and actually, sorry, we have to put employee file.read lines up here. And so now this will loop through all of the employees in this employee file.read lines array. So we can actually just print out the individual employee. And now this will print out all the employees inside of that file. So it's basically printing out each line in the file. And that can be pretty useful. So you can use all of these different functions like read, read line, read lines, readable. You know, there's a bunch of these different things that we can do to get information from a file. And so there's a lot of cases where you're going to want to be able to parse through information in a file, and this is an awesome way to do it. So just to recap, whenever you want to open a file and read from it, you can just use this open function, type in the name of the file and then the mode, which in our case is going to be R. Then you can do all sorts of stuff with it, and you always want to make sure that you close it when you're done. That's just good practice. So that's the basics of reading from files, and hopefully you guys can use this in some way, shape, or form in the future. In this tutorial, I want to talk to you about writing and appending to files in Python. So one of the cool things about Python is it allows you to work with external files. So I could have like an external text file, and I could actually like completely read all of the information in it. I could parse through it, use that information to do certain things. But in addition to reading a file, I could also write a file. And that's what I want to talk to you guys about today, is writing new files and appending onto existing files. Over here, I basically just have some code written out, and this essentially just reads information from this employees.txt file. So you can see over here, I'm specifying the mode, which is R, and that stands for read. And then down here, I'm just reading all of the contents of the file and spitting it out on the screen. So I'm gonna click the play button over here, and you'll see that this executes. So it's printing out all of the lines of code in our text file. So over here, I'm in this employees.txt file, and it just has all this information like employees in an office. But let's say that I wanted to add another employee onto here, right? Let's say that a new employee joined our company, so we wanted to add them onto this list. Well, I can come over here to my app.python file, and instead of reading from the file, I want to append to the file. So I want to say A. And appending to the file basically means that you're adding some text at the end of the file. So wherever the file ends, you're just going to add some text onto there. So what we can do is we can actually add another employee into the file. So instead of printing something out, I'm actually just going to say employee file dot write. And when I say employee file dot write, I'm going to be able to write something to the end of the file. So I can basically just write whatever I want. So why don't we add in another employee into our employees.txt file? So we can add in another employee. Why don't we say like Toby, and he's going to be in human resources. So now when I run this program, it's going to add Toby human resources onto the end of the file. So I'm going to run my program, and you'll see that nothing shows up down here in the console. But if I go over to my employees.txt file, all of a sudden we have a new entry over here. It's Toby from human resources, right? So I was able to append a line onto the end of this file. But here's the thing, you need to be careful when you're writing to files, because you can actually mess up a file very easily. For example, I already added Toby here into my file, but if I was to run this program again, you'll see that over here in this employees.txt file, it went ahead and added Toby again, right? So it added this employee here again. And also you'll notice that in this case, this employee didn't go on to the next line. I accidentally ran my file again, and all of a sudden it messed up this file over here. And so appending, you really need to be careful, because if you accidentally run your file again, or if you append something on something wrong to the file, it's permanent, like it's getting saved inside of the file. So I want to talk to you guys a little bit more about appending. Another thing we could do, let's say we wanted to add another employee, and you'll notice over here in this employees.txt file, when I appended it on again, it got appended to the end of the existing line, right? So the first time I had a new line there, but if you don't have a new line at the end of your file, and you want to add a new line, you're going to have to add some special characters. So let's add another employee, and we'll call her Kelly. And let's just say Kelly is in customer service. So Kelly is going to be in customer service. And if I want to add this employee onto the end of the file in a new line, I'm going to have to put a new line character in front of it. So I can say \n, and this will append this entry into the file with a new line, so on a new line. So now when I run this, you'll see we get Kelly from customer service on her own line. So you want to make sure that you're aware of like these special characters that you can use. They call them escape characters. And anytime you're adding onto a file, you want to make sure that you're adding on exactly where you want to add on. So in addition to appending to a file, I could also just like overwrite a file, or I could write an entirely new file. So since we already have this open, instead of appending to the file, why don't we just write a file. So I'm going to use this W. And now, if I say employee file.write, because I'm using W and I'm not using A, it's actually going to override the entire file, and it's only going to put this inside the file. So when I run this and we go over to this employees.txt file, you'll see we only have one line inside of this file now. It's just Kelly customer service. That's because I was using W, not A. And when you use W, it's just overwriting everything that's in that existing file. You can also use W to create a new file. So over here, I could say employee file is equal to employees1.txt. And now what's gonna happen is when I run this, it's gonna create another file for me. So I'm gonna run this, and you'll see over here in my file browser, we have this new file, employees1.txt. So if I open this up, it has exactly the same stuff as in this employees file. But it basically created a new file for us. And so a lot of times you're gonna wanna create a new file, and you can use different extensions too. So if I wanted to create like a web page, I could say index.html. And I could also add in some HTML code in here. So if you don't understand HTML, don't worry about it. But if you do, I could put like a paragraph in here, another paragraph, like this is HTML. Basically HTML is like a web page. And the point I'm trying to make is that you could write out a web page inside of Python by doing something like this. So now when I played this, we get this index.html file, and it has some HTML inside of it. So that's one way that writing to files can be really useful. You can overwrite an existing file, you can write a new file and create it, or you can append on to the end of a file. And there's tons of applications for writing to files, and Python's a great language for working with reading, writing, and doing all that stuff with files. In this tutorial, I want to talk to you guys about using modules in Python. Now, a module is essentially just a Python file that we can import into our current Python file. So, for example, if I wrote a Python file that had a bunch of like useful functions or useful variables or other things like that, I could take that file, I could import it into the file I'm currently working on, and I could actually access all of those functions, all of those variables, all the stuff from that external file inside the file that I'm currently working on. So I'm going to show you guys how we can use modules, and then we'll talk about where you can find awesome modules and really why modules make Python an awesome language. So over here in my text editor, I actually created this file, and it's called usefultools.python. And basically this file just has a bunch of sort of like useful tools that I might want to use in one of my programs. So you'll see over here I have some variables. This one is telling me how many feet are in a mile. This one's telling me how many meters are in a kilometer. And then we have this list here which lists out all of the members of the Beatles. I also have a couple different functions down here. So I have this get file extension function. And this basically just will, you give it a file name, it'll tell you what the extension is. And then we have this other function down here which simulates rolling a dice. So you pass it a number. If I pass it like a 6, it would roll a 6-sided dice. If I pass it a 9, it roll a 9-sided dice, etc. So this is like a Python file that I wrote, and it has some useful stuff in it. And honestly, there's a lot of stuff in here that I might want to use in the other Python files that I work with. So let's say I'm over here at this app.python file, and I'm thinking to myself, I think I could use one of those functions that was inside of that useful tools file. Actually, yeah, I need to simulate rolling a dice in my program. Well, instead of having to go over here, copy this function, and then paste it over here into my program, I can actually just import this useful tools file, and I'll be able to import all of these functions and all of these variables and attributes. So the way I can do that is just by coming up here, and I'm just going to go right at the top of my file, and I'm just going to say import, and then I want to type in the name of the file that I want to import. So I'm just going to say useful_tools. And Python's going to be smart enough to know that it should go off and grab all the stuff from this usefultools.py file. So once I've used that import statement, I can actually use all of the functions inside of that useful tools file. So for example, I could simulate rolling a dice. I could say useful tools dot, And now I'm actually able to access all of the attributes from inside that file. So when I say useful tools dot, you'll see down here in my little suggestions menu, it's telling me like beetles, feet and miles, get file extension, meters and kilometers, roll dice. So it's giving me access to all of the stuff that was in that file. So over here, I could just say like roll dice, and we could pass this like a 10. We'll roll a 10-sided dice. And now this should actually be able to run that function. So we'll simulate rolling a 10-sided dice. So you can see we got 4. And this is a really core concept in Python, which is importing functionality from external Python files. And this is like huge in Python, and this is seriously going to change the way that you create your Python files. So you'll notice like I didn't have to copy any functions or any variables or anything over into this file, and yet I was able to use all the stuff that was inside this useful tools file. So that is huge, and honestly, it's gonna save you a lot of time because you can write something once and then you can import it into your other files. And so that's really the basics of using modules. I mean, modules are very simple. A module is just any external Python file that you want to use some stuff inside of it. I want to show you guys a place where you can go to find a huge list of modules. So I'm going to go over here to my web browser, and I'm on this website. It's actually like the official Python docs. And basically all I did to get here was just type in list of Python modules in Google. And depending on the version of Python you're using, you're going to want to make sure that you click the right one. I clicked on the version 3 one. And over here on this page, you can see there's just a huge list of Python modules. And these are basically modules inside of Python that you can just access. So essentially there's like all of this awesome code that's already been written for you. And so if there's some sort of functionality that you want to have inside of your Python program, chances are there's a module in here that has that functionality. So there's all sorts of stuff you can do. I mean, if you just look through this list, like you'll see a huge collection of basically just, you know, a bunch of either Python variables or Python functions, just, you know, things that you can use to make your programs better. So here's what I would recommend. Like, head over to this page and just sort of look through a lot of these different modules, you know, see what you can see. And honestly, like if you click on one of them, it'll bring you to a page that talks about like how to use it. It'll tell you like how to import it and just, you know, some basics about it. And this is sort of like the list that's on the official Python docs. But here's the other thing. The Python community is huge. There's tons of developers who use Python, and you can actually find a lot of third-party modules. So if you just go online and, you know, look up like Python module for doing X or Python module for doing Y, chances are somebody out there has already written a Python module to do what you're trying to do. So if you get good at using modules and you get good at, you know, looking for them and finding them, you can actually save yourself a bunch of time, because chances are that somebody's already written a module to do, you know, what you're trying to do or like part of what you're trying to do. So now that we've taken a look at all these different Python modules, I want to just kind of dive in a little bit deeper into how we can actually use these things. So you'll notice here there's a lot of files, right? There's a lot of different modules that we apparently have access to in Python. But the question is, where are all these files stored, right? When I was over here in my program, for example, I was using this useful tools.py file. Like I knew where that was. I created that file. I was directly involved in making it, and I just imported it over here. It was pretty easy, right? But what about all of these files, right? What about all of these modules over here? Like, where are all of these stored? And there's basically two types of modules here. There's built-in modules, which means they're just built into the Python language, so we kind of just automatically have access to them. And there's external modules. And a lot of these external modules are just stored in basically the same folder that we installed Python on our computer. So for example, let's look at a couple of these, right? We have like base64, BDB, bin ASCII. Like if I come over here, and you'll see I'm over here in my little file explorer, I have my Python project, which is draft. There's also this other folder over here called external libraries. If I was to click down on this and I come down here, you can see it's just the version of Python that I'm using. There's a folder here called lib, and this is a very important folder. This is basically storing all of those external modules. So you can see if I scroll down here, we have all of these different like modules, right? So here's that base 64, here's BDB, right? A lot of these external modules are stored inside of this lib folder. And like I said, there's external modules. There's also a few modules that are just like built-in modules. They're not going to be stored inside of here. And you can actually tell. So for example, if I was to come over here and click on base 64, it tells me where the source code is. So the source code's in lib/base 64. We were able to see that, right? I saw that inside of my lib folder. This bin ASCII though, for example, if I click on this, you'll notice that this isn't giving me a folder because this is basically just like built into Python. So we don't have to worry about, locating that file. It's just kind of like, it just kind of works. So some of these are external, some of them are built in. And I want to show you guys, in addition to using these modules, right? So there's a lot of good stuff here. And honestly, you could spend, years and years just learning about all these different modules. But a lot of times you're going to want to use modules that other people have written. There's a lot of developers who work on Python and who write different modules. So there's a lot of useful modules out there that aren't included in this list, right? They're not going to be inside of this lib folder by default. And what we can actually do is we can install those external modules, those third-party modules that don't just come pre-installed with Python. And I'm going to show you guys how to do that really quick. So the first thing you need to do, obviously, is find a Python module that you want to install, that you want to download. And I have actually used one in the past, Python docs. It's an external module that you can use to basically use Python to create Word documents, which is pretty cool. So you can like format Word documents inside of it. So I'm just going to look that up here in Google. I'm just going to type in Python docs. And look, here's the thing. There's tons of these external modules. You don't have to use Python docs. I'm just giving you guys an example. But really, if you just look up like useful third-party Python modules, there's going to be lists of hundreds of these things online. In my case, though, Python docs has a website, and it basically just has like some installation instructions. So I'm going to come over here, and it tells me that I can install Python docs using the command pip install Python docs. So this brings us to something I want to talk to you guys about, which is pip. And pip is essentially a program. And actually, if you have a newer version of Python 3, it comes pre-installed with Python 3. And you can use pip to install Python modules. It's referred to as a package manager. And a package manager basically just allows you to like install, manage, update, and uninstall like different Python modules. So pip is extremely useful. And in order for us to install Python docs, we're gonna have to use pip. So I'm gonna show you guys how we can do that. What I wanna do is open up the command prompt or the terminal on my computer. If you're on a Mac, you wanna open up your terminal. If you're on a Windows computer, you wanna open up your command prompt. I'm using a Windows right now, so I'm just gonna come down to the search bar and type in CMD, and this command prompt should come up. So I'm gonna click this. Inside of the command prompt, we can actually use pip. The first thing we wanna do is just check to make sure that pip's installed. And like I said, if you have a newer version of Python 3, pip should come just pre-installed, and it should just work in here. If you don't have a newer version of Python 3 though, you might have to install pip separately. And there's tons of instructions online on how to install pip. So I'm just gonna check to make sure that I have it. I'm gonna type in pip -version, and this should spit out the version of pip that I currently have. So as long as we have pip, then we're ready to install an external or a third-party Python module. All I have to do is just say pip install, and now I just want to type in the name of the Python module. So in the case of Python docs, it was just Python docs like that. Now again, you don't have to install Python docs. I'm just doing this for this tutorial just to kind of show you guys how this is going to work. But what you want to do is go online and look up some third-party external Python modules. And generally, like I'd say 90 to 95% of the time, you're going to be able to just install them using pip. In the off case that you can't install them using pip, chances are there'll be like some detailed installation instructions. But I would say for the most part, any like legitimate Python module is going to be able to install it using pip. So over here, I'm just going to say pip install and then the module name. So Python-docs. And when I click enter, this is going to go off and install Python docs for us. So I'm just going to click enter, and it's going to go off and install everything we need for Python docs. So you can see we successfully installed Python docs 0.8.6. So I'm going to show you guys where exactly this got placed. So normally when we install a external third-party module, it's going to get put inside of this lib folder, but it's going to get put inside of a special folder in here called site packages. So site packages is a special folder, and if I open this folder, you'll see now we have this docs folder, and we also have this Python docs 0.8.6 py 3.6.egg info folder. So these two folders are basically included in that module installation. So you can see this docs folder has a bunch of different Python files and has a bunch of stuff in here that we can use. So if I wanted to use this inside of one of my programs, I'm just going to refer to the name of the module. So in our case, it's just going to be docs. So I used Python docs in order to install it, but we're going to use docs if we want to import it. So I could come up here and I could say import docx, and now I can actually use it. So I could just say like docs dot whatever, and you can see there's a bunch of different stuff down here. There's like a document part, image part. There's a bunch of stuff that we can use with this, and obviously depending on the Python module you install, there's going to be different instructions. But you can see it got stored down here in this site packages folder. If I wanted to remove this, I could use pip to do it. So I could just say pip uninstall, and we could just, again, say the module name, so Python docs. And pip will now uninstall this on our computer. So if I was to go back over to this folder, you'll see that those two, that docs folder and then that other folder disappeared. So they're no longer here, and I'm actually not going to be able to use this anymore. So that's sort of the ins and outs of using modules. Now again, there's tons of these modules, and I can make dozens and dozens of Python courses covering each one of these modules. The built-in modules, the modules that are included by default, and external modules. There's tons of these things out there. And really, as a Python programmer now, what you can do is you can go out and play around with these different modules. I showed you the ins and outs of installing them, and you can use pip to install all these different modules. And you can make sure that you have them by checking the site packages folder or the libs folder. But really now it's on you to just kind of go out and use these modules, and don't shy away from this, because modules are a huge part of Python, and you're definitely going to want to include them in your Python stack. In this tutorial, I want to talk to you guys about classes and objects in Python. Now, classes and objects are extremely useful in Python programming, and they can help you to make your programs more organized and more powerful. So when we're in Python, we're dealing with all types of data, right? And a lot of times when we're writing programs, we're going to have to work with different types of data. And there's essentially like a few basic types of data we can deal with, usually things like strings, so like plain text, numbers, and Boolean values. Those three are kind of like the main types of data that you're going to be working with in Python. And we have all sorts of structures we can use to store that data, things like lists or dictionaries. But here's the problem, is that not all information, not all data, not all things can be represented using strings, numbers, or Booleans, right? There's a lot of things in the real world that we can't represent in something like a string or just a number, right? In other words, think of something like a phone or a computer or a person, right? You can't really represent those things in like a string or a number. In other words, like the data types that we have available to us in Python can't cover that. And so what we can do with classes and objects is we can essentially create our own data types. So I can create my own data type for anything I want in Python. So I could create like a phone data type, and it could represent a phone. So I could store all the information I would ever want to know about my phone inside of that data type. And in Python, we could create a class for it. And essentially what a class is it's just saying, hey, here's another data type that we want to use in Python. So with a class, you can essentially define your own data type, and it's super awesome. And classes are extremely useful. Classes are used in almost every single major programming language out there. So in this tutorial, I just want to give you guys a basic introduction of classes and using them inside of Python. So let's say that I'm writing a program and I want to represent a student inside of this program. So maybe I'm writing a program for like a college or a university. Let's say that in this program, I want to model a student. Like I want to model a real world object and I want it to be a student, right? Well, we don't have a student data type, and I can't really represent a student in just a single string or a number. So what I can actually do is I can create a class for a student, and I'm basically creating like a student data type. So I'm going to show you guys how we can do that and create our student class. So over here, I'm just going to make a new file. We'll just make it a new Python file. So I'm just going to call it student.py. And inside of this student.py file, I want to create a student class. So the way that I can do that is just by typing class. And now I want to type the name of the class that I want to create. So in our case, we're going to create a class called student. So I'm just going to say student, and now we're going to make a colon. Now everything that goes inside of here is going to be inside of our student class. So everything that's indented like this will be considered a part of our student class. And basically what we can do inside of this student class is we can define a bunch of attributes about a student. So essentially what I'm doing is I'm like modeling a student. I'm creating our student data type. And I can use things like strings, integers, and booleans in order to map out what a student should be and what a student should have. So I want to create something called an initialize function. And the way I do that is just by typing out def, and I'm just going to type 2 underscores, and then the word init, and then 2 more underscores. And you also want to type out open and close parentheses, and inside of those parentheses, we want to type out self, and then we want a colon after that. What I can do inside of this initialize function is I can basically map out what attributes a student should have. So we can essentially define like, hey, here's the student data type in Python. So what I want to do is add in certain attributes after this self. So I'm just going to say self, a comma, and now we can start thinking about, what values will represent a student inside of our Python program. So if I'm thinking something like name, right? So every student in our program should have a name. They also might want to have a major because they're in college. They probably also will have a GPA, so their grade point average, like how they're doing in school. And let's define one more thing. Let me think. Why don't we make a Boolean, and it's going to be called is on probation. And this will basically tell whether or not the student is on probation. So essentially what I'm doing inside of this initialize method, inside of this init function, is I'm defining what a student is in our program. And so in this program, a student has a name, it has a major, it has a GPA, and it has a value that determines whether or not it's on probation. This right here is the student data type. So if I'm representing a student inside of my program now, it has all of these attributes associated to it. And that's basically what I'm doing up here. Now, inside of this initialize function, we actually have to do something. And basically what I want to do is assign some values. So I'm going to be writing out some stuff, and this might not make total sense right now, but this is going to make sense in a second after we create our first student object. So just stick with me right now and just basically know that we have to do what I'm doing over here. So I'm just going to say self.name is equal to name, and then I'm going to say self.major is equal to major, self.gpa is equal to GPA, and I'm going to say self.is on probation is equal to is on probation. So again, this might not make a whole lot of sense right now, but in a little bit, this is going to make total sense. So now that I have this student class defined, I can actually use this class inside of my other files. So I'm going to come over here into this app.python file, and this is just my main file. And so I actually want to create a student, right? So in that student class, we defined the student data type. And we basically said like, hey, a student has a name, a major, a GPA, and it says whether or not they're on probation. That's like the template for what a student is. But we can actually create a student. So we can create an actual student and give it some information. And that's called an object. So this student class over here is basically defining what a student is. So a class is just like an overview of what the student data type is. An object is an actual student. So it's an actual student with a name, a major, and a GPA. It's not just this template anymore, it's actually like a student that we're representing inside of our program. So in order to use that student class and create a student object, I actually need to import that. So all I have to do over here is just say from student, and this is referring to this student file. I can say import student. And basically what this is saying is from the student file, I want to import the student class. So even though these are both student, they're referring to different things. So this is referring to the file, and this is referring to the actual student class. So now that we did this, we can create a student. So you can create an object of a class a lot like you would a normal variable. So I can just give it a name. I'm gonna call this student1, and I'm just gonna set it equal to student, and I'm gonna make an open and close parentheses. And now inside of this parentheses, I want to give this student a name, a major, a GPA, and an is on probation value. So I'm going to say, we'll just create a fake student. So I'll just say his name's Jim, and he's studying business, and we want to give him a GPA. So maybe he has like a 3.1. And finally, we want to say whether or not this student is on probation. So why don't we say false? So basically what I'm doing is I'm saying that I want to create a student. So I want to actually create a student object. And remember, an object is just an instance of a class. So the class is like an overall template. It defines what a student is, but an object is an actual student with actual information. So we could call student1 now, this is a student object. So I just want to show you guys what this student object actually is and what we can do with it. And then I'm going to talk some more about that init function from before. So over here, I'm just going to make a print statement. And inside of here, I just want to print out student. And what's cool about this student1 object is I can actually access each of the attributes from inside of this object. So if I wanted to get the name of the student, I could say student1.name. And now this is actually going to print out the student's name. So over here, you'll see it prints out Jim. If I wanted, I could print out the student's GPA, and it's going to print out the student's GPA, 3.1. So now that I created this student object, I can actually access the information about the student. So essentially, I've just created a student data type. So I could create as many of these students as I wanted. If I wanted, I could create another student. We could call it student2. And essentially we do the same thing, we just give it different information. So we could say like Pam, and her major is art, and she has like a 2.5, and let's say that she is on probation. So now I have another student, student2. So if I wanted, I could access information about that student. We could say like student2.gpa. And now this is giving me the GPA of student2. So basically what I did was I created a student data type, and I created student objects, and now I'm able to represent a student inside of my program. So let's talk real quick about all this stuff over here, because I didn't really explain it. Basically what's happening is when I come over here and I say student, and I'm passing in all of these different values, those are getting passed into this init function. So remember, I passed in a name, I passed in a major, I passed in a GPA. When we create that student, we're actually calling this function. And when I pass in the name, the major, and the GPA, those values are actually getting stored over here in this name, this major, this GPA, etc. Right? So I'm giving this student object all of that information. And down here, what I'm doing is I'm saying self.name is equal to name. And basically what this means is the actual object's name is going to be equal to the name that they passed in. So self.name is an attribute of student, right? So the student is storing a name, the student is storing a major, the student is storing a GPA. But that's different from this name, this major, and this GPA. Remember, these are all just values that I passed in. They're just parameters. And so I need to take the values that I